everybody, today we are debating creation evolution and we're starting right now. Ladies and gentlemen, thrilled to have you here for another epic debate, as today we have Erica and Standing for Truth joining us for round 2. It's going to be an epic one, folks, and want to say if it's your first time here, consider hitting that subscribe button, as we've got a lot more debates coming up. In fact, you'll see at the bottom right of your screen, Endgame, the final chapter between Mark Drisdale and Kent Hovind will be this coming Tuesday. So our last debate between those two gentlemen, as it's always been fun to watch them, and so that's one you don't want to miss. You can set a reminder. So with that, want to let you know we are very thankful to have our guests here. In fact, not only that, but we're also giving a special thanks to Erica. She's a night owl, but nonetheless, it's impressive. She's over in London. Is it London right now, right?
Yeah. You can see my change of scenery. I'm in my normal living quarters. This is my flat, so I've got all the decorations up. Anybody who's subscribed to my channel, this is a familiar scene. So got the whales right here. It's gonna be great. I'm ready.
Epic, very exciting. So it's going to be a fun one tonight, folks. We are really looking forward to it. I want to let you know what we are going to do for format. I'm going to pull up on email because I'm trying to remember, unless one of you remembers. But
yeah, we're doing 5 and 5 short intros and then open discussion. Yeah, Standing.
Very good memory, Erica.
Hey, that's what I do.
Gotcha. Perfect. So it'll be, if I understand right, 5 rounds of 5 minutes. Is that what you're saying?
I mean, I thought it was openers and then open discussion.
Right. Yeah. No. It's
gotcha.
5-minute introductions and then just open discussion and then Q&A, I'm guessing.
Thanks so much. Appreciate it. Long day already.
That's the fun way to do it, anyways.
You
That's
betcha.
what we're here for, James.
Stoked for it. Thanks for that refresher. And want to let you know, folks, if you have any questions, fire them into the old live chat. I will pull those questions out of the live chat, and we'll ask as many as we can at the end of that open discussion section when we get into Q&A. If you want to do super chat, that's an option as well, in which case it'll push your question to the top of the list for the Q&A, and it allows you to make a comment toward one of the speakers. Of course, they'd get to respond to it, and we ask you to be your regular friendly selves for that. And so with that, very excited, folks. I am going to set the timer for 5 minutes, and my presumption, because usually it's just the habit, we always have the creation person go first. Standing for Truth, do you want to go first, or did you already decided that, did you guys already decide together that Erica would go first?
I don't think, we didn't have a choice, but I don't care.
Yeah, it doesn't matter to me. I mean, to be fair to Erica, she started first last time, so I don't mind starting first this time, but ultimately it's up to you.
Deal. Yeah, sure. You can start. Yeah, I always start. You start.
You bet.
Only fair.
Okay, let's timer set. Standing for Truth.
Awesome. Well, thanks so much. Thanks so much for doing this, Erica. The first debate was a blast, so I'm really excited for this one. And James, as always, brother, thanks for setting it up. So before we get started, we all must realize that it's genetics. It's in our DNA where the question regarding ancestry is answered. Genes, traits, genetics is what's inherited sperm and egg. Sperm and egg don't pass on a fossil or a bone. They don't pass on geography or a rock. They pass on genetics and traits. And so if we want to find out the history of humanity, this is where we must look. We have clocks in our DNA, for example, that go back just 6,000 years to Adam and Eve. Let's discuss some reasons why, based on genetic data, the Bible's account of human history is true. When we focus on the variation, for example, in the Y chromosome in the world today, we see that Y chromosomes have very little variation. This indicates that we came from a common ancestor in the not so distant past. Interestingly, the Y chromosomes are geographically specific. There exists African Y chromosomes, British Y chromosomes, Chinese Y chromosomes. Why is this? This is because mutations have occurred in the lines after Babel, since God divided the nations based on their Y chromosome. The family lines are based on the male ancestry. These nations were divided across the planet. Is there good evidence for limited ancestry? Or does the evidence tell us that humans did not go back to Adam and Eve, but are actually related to apes, dogs, and banana plants? Well, the evidence for the existence of Adam and Eve and limited ancestry is you and me and the genetics of the people in the world today. The genetic structure in humans today speaks to us of a literal Adam and Eve. We have a small DNA compartment called the mitochondrial DNA that we only inherit from our mothers. Everybody on this planet got their mitochondrial DNA from a single woman, who is exactly what we would expect from a biblical Eve. She is quite literally the mother of us all. In a nutshell, we have nearly identical mitochondrial DNA, and the very few mutations that differ from Eve's sequence are exactly what would be expected if Eve arose just several thousands of years ago. As I briefly touched on earlier, the same thing goes for the male side. Science tells us that all men have similar Y chromosomes, which is passed down from their fathers. And all of male humanity traces back to a single man. This single male ancestor of humanity has all the qualities expected if the Bible were true. The main argument offered, though, by the evolutionist community, especially biologos, against a literal Adam and Eve and ultimately limited ancestry has to do with genetic diversity. They will say there exists no real scientific way for two people to generate all the genetic diversity we see in humans today. This main argument is easily refuted and actually reflects a poor understanding of even basic genetics. A man and a woman today could have thousands, even millions of children, and no two children would be 100% identical. This is because they are heterozygous. There exists built-in diversity in millions of sites within the genome of the average person. In the limited time that I have here, the best way I can explain it is if God created Adam and Eve to be heterozygous, which in fact would be optimal design, you could have as much human diversity and more than we have today in their first family. Time is not required for the diversity today because diversity can be designed and built into Adam and Eve. This argument is not even scientifically reasonable. One more line of evidence I do want to point out before we go into the discussion has to do with the HapMap data. The HapMap project is what I am referring to, and this very important project was intended to compile a significant fraction of human genetic diversity. They examined millions of variants in thousands of people from around the world and made the data easily available. Dr. Robert Carter puts it perfectly when he states, and I quote, "I am quite happy with what we learned from the project." What have we learned? The human genome is young. Shared blocks of DNA are large, and there has not been enough time to scramble them to randomness. The human population came from a single source. Most blocks are shared among all world populations. The human genome is falling apart. Deletions tend to not be shared among populations, but are unique to subpopulations. This is further evidence for the youth of the genome, and that we came from a single source population in the recent past. I've got 10 seconds here. Genetic entropy, orphan genes, the chimp Y chromosome, endogenous retroviruses, linkage blocks, for example. There's many different lines of evidence we can look to that point to limited ancestry, and I'd be more than happy to discuss any one of these topics with Erica and show her why limited ancestry is true and universal common ancestry is false. Thanks so much.
Thank you very much, Standing for Truth. Just several seconds over. We'll give Erica the same leniency. So with that, we will jump over to Erica's opening statement. Thanks again for being here, Erica, especially given how late it is. It's a pleasure to have you.
Please don't worry about it. I will, if that's okay, share my screen. I know I normally have my nice monitor up, but I don't have anywhere to put it. So
happy to do that.
If that's cool, it's just a PowerPoint. I've never done the screen share thing, so bear with me, you guys.
Totally.
Here. All right, share my screen, and then can you guys see that?
It's now showing. So let me just squeeze it down to make it fit.
And I'll do one of those. Does that work? Okay. Very cool.
Almost there. 3, 2, 1. Okay, and we're set.
All right. So biology supports a universal common ancestry. This is the argument that I am going to make today. Now, generally speaking, when we look at a universal common ancestor, what we're kind of referring to is that all life on Earth shares a common ancestor in the form of a single-celled organism some 3.8 billion years ago. Now, as Standing mentioned previously, his argument is somewhat different in that he's sort of going for the creation orchard, so to speak. So if you can see in this picture here, this would be Standing's creation orchard on the left, where we have several sort of nodes that are acting as creation origin kinds, right? And the diversity within those kinds is stringent and kept separate from one another. Now, of course, my position would be the conventional tree of life, which is here on the right. So the question is, why do all of the fields in biology agree that universal common ancestry is indeed sort of the reality that we live in? And the reason is because, at least in my opinion, in my humble opinion, it is the case. This is, in fact, our reality. We can look to genetic support, we can look to paleontologic support, and we can look to morphologic support. Now, as Standing said, we're probably going to be talking mostly about genetics today. So while I included some slides here on paleontology and morphology, which I will skim if I have the time, we're mostly going to be considering genetics. So I've harped on this many times before in other debates and in other conversations, but genetics by definition dictates relatedness. This is simply the case. The same sequencing that links humans to all other humans links us to the other apes, all the mammals, all the chordates, etc. So when you look in this picture, again, as I've said multiple times before, the same logic, the same genetic sequencing, the same means by which we develop phylogenetic trees, Standing would agree within sort of the kinds. Like creationists tend to use kinds, sort of structure their kinds with genetics as well. The question is, can the lines cross? And my argument here is that there is no empirical reason to suggest that they would. There just isn't. It's a smooth gradient. And I've said this before too, but the sort of the same process that we use to allow paternity tests to be considered admissible in court. We use to reach the 98.8% similarity between us and the members of genus Pan, and then indeed 92 with the macaques, and so on and so forth. So in addition, we could talk about endogenous retroviruses. Now here I've linked a couple of nice papers that cover the similarities of the ERVs between us and the chimps. And we have this nice little quote on the side that you can read if you like, which, to summarize it, 99.9% of ERVs in humans are at the identical location and are structured identically between us and the chimps. And even when we look at these specific ERV insertions, we find that the mutations that those ERVs experience in and of themselves are also identical, which means either we're dealing with a completely separate event for every single ERV in every single primate lineage, both within and without or outside of the human and the ape kind, and I'm the monkey kind, I'm not sure how Standing structures it, or we're dealing with a common ancestor. So my question would be, why can creationists not draw these lines between the kinds? Why do we see this smooth gradient that I've been sort of alluding to? You can sort of see the same thing when we look into deep homology, which would be kind of the argument that we're dealing with the same building blocks. So geology and paleontology, of course, continued to confirm common ancestry, and not just that, they preclude a 6,000 to 10,000-year-old Earth. Now, I know it might seem sort of tangential to bring this up in a conversation about genetics, but in genetics, we get sort of divergence times using molecular clocks. And interestingly enough, radiometric dating, a completely isolated physics-based sort of just equation that we use to measure radiometric or radioactive decay, confirms this. They corroborate one another. And not only that, but paleontological evidence can also be corroborated with other methods like ice cores or dendrochronology or natural nuclear reactors like the Oklo reactor. Then, of course, there's morphology, atavisms, vestigial structures, deep homology. Here are some nice pictures. Sometimes we see horses, display these additional toes that they used to have when back with Eohippus and the like. Vestigial pelvises, which I know some people say have a function in copulation, but not so. Ask any of the whales that require a third party to mate. We see deep homology in the form of the PAX6I gene. Rector pili with our hair standing on end, and of course our wisdom teeth. None of these make sense when we're sort of taking this idea of a designer into our mind. And I know that genetic entropy is going to be brought up, and that's the reason why we have these sort of degenerate traits, but I'm ready to have a conversation about that. So my question for Standing is sort of threefold. Well, I think there might be more than three, but where and more specifically, why do you draw the lines between the kinds? And what separates the humankind from the ape kind? You can do this genetically or otherwise, I don't care. Another one is, how can limited ancestry account for the gradient of forms that bridge the kinds in the fossil record? So here we have an amphicyonid, and we have a wolf, and we have a grizzly bear. Now, morphologically, it essentially looks like you took 50% of the traits from the amphicyonid and then sort of parceled them out into these two very closely related animals that we have today. And lastly, why do we see atavisms and vestiges in nearly every animal? And why do these vestiges seem to indicate and suggest that they're from our genetically derived ancestors? Why do they match evolutionary theory? What's the deal with a whale having a pelvis and then also us finding similarly structured organisms living in the same location with the involucrum, which is an inner ear structure unique exclusively to the cetaceans, and through geologic time? So these are sort of my questions for the conversation, and that's it.
Thank you very much, Erica. So now we will switch back over to, or I should say we'll switch into open discussion section. So I will close your share screen. And gotcha. Okay, thank you. Very sassy. I appreciate that. Next, we will go into the open discussion section. So very exciting, folks. And the floor is yours. Thanks for being here again.
Yeah.
Awesome.
All right, Standing, where do you want to start? You get to pick because that's how we did it last time.
Sure. Awesome. Well, I appreciate your opening. Thanks for the visuals. Definitely lots of good questions, lots of good topics. Since you started off with ancestry anyways and where we can draw the line and kind of how there's a perfect gradient, a perfect nested hierarchy of life, I guess you can put it. My question to you then would be regarding certain taxonomically restricted genes that we can look to separate ancestry, right? So if we're going to look at limited ancestry, for example, if we look at orphan genes, and orphan genes, they lack similar counterparts in other organisms, as in like there's no evidence for common ancestry with, say, humans and chimps because of these taxonomically restricted genes that are specific to humans and then also very specific to, say, chimpanzees or like the cat family.
Or well, sure, of course there would be, because the divergence time between humans and chimpanzees, the divergent time would be approximately 13-ish million years ago, with the speciation time being 6 to 7, give or take. So that's plenty of time for you to get emergence. That's of sort of genetic novelties. That's why we have ERVs that are also unique to humans. But you can point to those, and the exception does not make the rule. You can't point to the exception and say, oh, look, there are, individual ERVs or orphan genes, et cetera. I don't know nearly as much about orphan genes as I do about ERVs. But then I will simply turn and point to the 99.9% of ERVs that we share that are identical and in identical locations. So are you suggesting, just to kind of turn that into a question, are you suggesting to me that there have been separate genetic events regarding sort of these ancestral viruses for every single primate lineage, and then also humans, who I'm assuming you wouldn't accept our primates?
So good questions. I definitely want to talk about the endogenous retroviruses, but going back to the orphan genes first, as a counter to that, the orphan genes, for example, they're fully functional gene sequences, and what they do is they code for both a functional messenger RNA and a protein, okay? These orphan genes, though, Erica, they don't fit the hypothetical fairy tale of evolutionary theory, and our prediction based on ancestry and proving limited ancestry would be function, okay? So if these orphan genes, which according to our model are needed for the uniqueness that's associated with each created kind, as, say, described in the book of Genesis, which obviously we look to as a starting point, the fact that this amazing category of genes are taxonomically restricted and extremely functional and unique to each type of organism would suggest a limited ancestry, for the main fact that they are fully functional. I mean, how did these come about in separate ancestries according to the evolutionary theory? I want to just make an analogy real quick, just for the audience. It's
Sure.
like looking at 3 different books and then finding specific words that have important meanings in the different books that aren't found in all 3 books, right? There's no evidence for any type of ancestry. That's why they call it orphan genes, right? There's no actual evidence for the ancestral genes leading to these genes. So I mean, how would those pop up in evolutionary theory?
Well, I'm asking though, why are you yes, things can be taxonomically restricted. I mean, obviously there are, as I said previously, there are sort of unique ERVs to humans. There's also unique breakages like that are just in the primate order. There's a breakage that does the same thing, the gulo breakage, that also exists in guinea pigs, but it's very different. It's in a different location, and it lacks some of the sort of regulators that ours has. So I'm kind of wondering why it is that you're suggesting that in any shape, form, or fashion that these orphan genes cannot emerge after splits, after divergence points.
Well, I mean, it can be suggested that they do pop up. Like, I believe that the evolutionist explanation is de novo gene synthesis, that they popped up through the non-coding regions of our genome. But the question is there any empirical observational data for that occurring? And the fact that they've popped up to be extremely functional in the genome seems to be more ad hoc, post hoc reasoning. But if I'm arguing for limited ancestry and these types of taxonomically restricted genes that are extremely important in the genome, or what are expected to be found, and this is exactly what is found.
Right, but what you're doing,
this would suggest limited ancestry. It's exactly what we expect to find. Go ahead.
Right, but you've got to. I think a clear distinction has to be made. So when we're looking at data in general and we're trying to support a hypothesis or see if the data does support a particular hypothesis, it can. Obviously, as we know in the nature of science, data can support multiple hypotheses. But the sort of the issue with this is you're suggesting the orphan genes. Again, that's kind of why I wanted to make it more about biology in general, because I'm not a geneticist, but I know enough about it. Yeah, but I know enough about genetics to know that these kinds of sort of emergent genes, ERVs, etc., things like that, they don't preclude evolutionary theory in any way. You're arguing that it supports limited ancestry. And again, I don't know enough about it. It may support limited ancestry, but it also doesn't preclude evolutionary theory and universal common ancestry. And in light of pretty much, in my opinion, everything else that sort of I brought up in my presentation that I'm sure we'll touch on later, which not only does it support universal common ancestry, but it also precludes limited common ancestry. You see what I'm saying? Because there can be data that's like, it fits both frames. Like I know Jensen likes to do that with nested hierarchies, which I disagree. But the fact of the matter is then he turns, and I'm sure we'll do the same thing, and covers other subjects that he believes supports limited ancestry by precluding universal ancestry. Well, right, so it sounds to me, you get what I'm saying. Sorry.
Right, yeah. And if we look to homology, right, engineers build in a homologous type pattern, or we can look at DNA level nested hierarchies. We can look at nested hierarchies on an amino acid level, right? I know Dr. Herman Mays likes to look at neutral variation, for example, but when there are competing hypotheses, we need to look at lines of evidence that can differentiate between the two. Now, I disagree.
Absolutely.
Right, but I disagree with your point in that orphan genes can be explained through fish to fisherman evolution because of the important functional roles that have been discovered in them. They are taxonomically restricted, and I've yet to hear an explanation from you as to how these orphan genes can pop up, can be specific to lineages, for example, humans, to the great ape family, to the cat family, to the dog family. How are these popping up and having very important functional roles? I mean, that doesn't just happen. We also don't see that empirically in the lab. That's the thing. There has to be some type of explanation in order to have that competing hypotheses, but I don't see no explanation for these.
That's
why they call them orphan genes. That's it. You know,
sure.
they belong in specific taxons, and that's it.
Sure, but you're suggesting that the existence of, and I know that you mentioned that sort of the conventional science side that would say, okay, well, it's kind of this de novo emergence, but that does happen. I mean, I know you're frequently a fan of using ERVs that play roles in embryologic development because they've sort of been retrofitted. That's like a huge tenet of evolution, the atavisms, right? Like this idea of taking something that used to do something else and or not atavism, sorry, in some cases of vestiges, and using it for something new. I mean, because you're right, most ERVs though have zero function, but some of them do, and they did pop up, right? At least according to
real quick before you get, I understand that you want to move on to the endogenous retroviruses. Just to kind of end the part on orphan genes, we can do that. I don't want to beat a dead horse. Let's move on to endogenous retroviruses and retrotransposons, for example. I would just disagree that orphan genes aren't a line of evidence that can differentiate between the two hypotheses, right? Universal common ancestry and limited ancestry. We can just agree to disagree.
And we can.
Want to look to the de novo gene synthesis, we definitely need to see empirical data, whether it's in the lab or some type of technical paper that can actually show a non-coding region of our genome suddenly pop up and become functional as a protein coding gene.
So I kind of know where this is going. So I am going to openly in front of everyone make sure that this is clear. I don't know very much. In fact, I know very little about orphan genes. What I do know quite a bit about, or a decent amount about, is endogenous retroviruses. And the reason why I'm making the connection is because it sounds like conceptually there are quite a few similarities. So I'm not saying that I know enough about orphan genes to say this is certainly the case. I probably need to look into it, but I don't particularly find presenting a piece of evidence that, knowing absolutely nothing about it except for the blurb that you've given me here, could go either way in light of everything else that we're getting ready to discuss, convincing as a gotcha. You know what I mean? Because it sounds very similar
to many lines. I agree.
It sounds similar to the gotchas that creationists use with ERVs. That's why I keep making the comparison. Not because I'm trying to dodge away, I don't want anybody to know I don't know very much about orphan genes. I don't. I'm not a geneticist, but that's the way the cookie crumbles sometimes. So I'm just saying I don't find that convincing. I mean, if there are, geneticists out there who are saying, yes, de novo orphan genes can happen, then the fact that we have de novo ERVs, emerging from ancient viruses and such things like this, and of course new information through various mutations, I don't see a problem. It's completely in line with other conventional arguments that we're going to talk about.
Right. If I could just jump in real quick, because I definitely want to jump into the ERVs and the retrotransposons, and I'll give an answer to that. Just on the orphan genes and in the, it's not necessarily just a gotcha type argument. I will go on record that, the evolutionist community, they are somewhat baffled, and that is why they look to de novo gene synthesis. But to me, that's more of a circular argument, because the evolutionists know that orphan genes exist. Therefore, they need to hypothesize, why do they exist? So they resort to de novo gene synthesis. Well, why do they resort to de novo gene synthesis? Well, because orphan genes exist. So I'm just saying it's more of a circular based argument. Now, when it comes to the co-option in the functions found in endogenous retroviruses, I agree that these endogenous retroviruses, or the retrotransposons, for example, Erica, they are shared among humans, among some of the apes, of course. You can find nested hierarchies in the placement and positions of the ERV. So I agree with that. But the question I think we need to ask ourselves, Erica, is what are these endogenous retroviruses? What are these retrotransposons? Are they actually the leftover remnants of viral infections in our DNA, like you're suggesting, right? Or are they, say, created units of DNA function? Because for years, Erica, it has been assumed that they were the former. right? The leftover remnants of viral infections. And that is because, like you iterated in your opening, they bear strong similarities to actual viruses. And this predicts that these sequences are non-functional. And I know you look to co-option as an answer to the function, but this is a testable prediction based on the design model, and we are beginning to accumulate data. So what we do know at this point in time, Erica, is the trajectory of experimental results, and the trajectory points to increasing and surprising levels of function. So to me, it looks as if these are not remnants of viral infections, but actual functional DNA units. Now,
Right.
what's their
So,
role in ancestry and in speciation? But this specific prediction, it does differ from creation and evolution expectations. Go ahead, take as much time as you need, Eric.
sure. So I'm going to kind of respond to that in twofold. One, I'm not kidding here. We do know of a lot of endogenous retroviruses. We're not completely in the dark about this, and I know of like a handful that actually do something. And so I'm kind of wondering where you're coming with this sort of concept of, oh well, the trajectory is we're going to find out that they have more function, and I think I know where you're going with it, and I think it has to do with the ENCODE project, because I've heard you speak sort of before on ENCODE, and for those of you out there who don't know, ENCODE was a sort of group that did quite a bit of genetic work on discovering the functionality of the human genome, and they came out with this quite large number, 80%. They came out to say the human genome was functional. Now, their definition of that sounds impressive until you actually read the work.
Erica, I don't want to interrupt, but I feel like ENCODE in general is. I just feel like ENCODE at this point is kind of a rabbit trail, because we're specifically on the endogenous retroviruses.
Sure, but you'll see the point I'm going to make. It's relevant.
Okay.
Because I actually watched your discussion with your series of discussions with CRISPR earlier today, and you mentioned several times this concept of, oh well, the trajectory seems like we're going to find a lot of functions, but so I thought to myself, okay, well, time to look into that. Let's see, because I know CRISPR was saying no, absolutely not. The vast majority of people in the field are saying, similar to ERVs, no, it's not looking like we're going to find more function, because every time they investigate, they find a function for something new. It makes up a smaller and smaller and smaller proportion of the genome. And there was a paper that came out in 2017, very recently, that put an upper cap and very unlikely upper cap of 25% of functionality, with a likely range of 10 to 12%. So that's the most recent literature on that, and it doesn't follow the trajectory that you were mentioning. So I don't think that you can say, because you find functions in one ERV, or you find a little bit of function in say, an intron or whatever, you can't just say the trajectory seems like we're going to find more and more, and then eventually we find out all ERVs are functional, or all of the human genome is functional. That's all I had to say. That was the connection.
Oh, awesome. And I appreciate that response and those points as well. And I did enjoy my discussions with CRISPR, and would definitely recommend anybody watch them. But you say that like just one endogenous retrovirus, for example, was found to be functional.
Oh, that's hyperbolic. I'm sure it's more than one, but continue.
Okay. No problem. Even in the ERVs though, it's not just low levels of function. And that's the problem that the evolutionist faces, because the ERVs, they actually have crucial functions, Erica. For one, they help regulate genes. So they're not just functional in the embryo. They help regulate genes and even determine cell types. So I know that you're claiming that they were co-opted, but I would just say that that's mere uninformative gloss, because I would have to see empirical evidence, whether it's in the lab or some type of technical paper, that actually shows us a non-functional endogenous retrovirus going from non-functional to extremely functional in determining cell types or regulating genes. Before I continue, actually, would you be able to present something like that?
Hold on. What I want to talk about is your request there. You're saying, okay, well, I want to see.
I'm not saying you have to present it right now, but does something like that exist, where it has been observed empirically that a non-functional endogenous retrovirus went from non-functional to a functional DNA element, important in the embryo, important in regulating genes, important in determining cell types? I mean, could you present that to us?
I mean, I would say you've already done so, because we have, what I mentioned earlier, right, is that we have several, and what you agreed to is that we have, so many non-functional ERVs, you can't hardly list them out on a piece of paper. And then we proceed to talk about a functional ERV. So I think the burden of proof is on you to find function for them. If the vast majority is non-functional and you're making the claim that functions do exist for all, or at least the vast majority, the burden of proof is on you to show that they have function, not on me because we have point A and point B.
Well, real quick.
This would be like
you brought up real quick, I don't want to, because you brought up some things about ENCODE. I was kind of just clarifying with you, and I want to kind of touch on everything, because it's not just one or two ERVs that are being found. I mean, there's accumulating paper after paper. I mean, I've got papers here from 2019 that are now showing these ERVs. They frequently act to distribute regulatory information and thus confer genes with new patterns of expression and function.
I don't doubt it. I don't doubt that there are tons of ERVs that have functions. The problem is, and I checked today, the vast majority of ERVs are functionless. And
have they functionally tested the vast majority of endogenous retroviruses, though? Because remember, real quick, evolutionists assume, and you admitted it earlier, that the vast majority of our genome is based on genomic fossils, evolutionary leftovers. But far from being junk DNA, the pervasive retrotransposons, or the endogenous retroviruses, for example, that populate our genome, they have a powerful capacity to influence genes and even chromatin. I mean, the functions are endless. I can go on and on. Even the pseudogenes. We're finding. Well, I'm saying that your argument about co-option and suddenly the burden of proof is on me is more of a circular argument, just like with the orphan genes and de novo gene synthesis. So you're seeing that these real quick, I'm almost done. You're seeing that these endogenous retroviruses are playing very important functional roles in our genetics. So instead of actually giving us and providing us empirical evidence for the co-option of these endogenous retroviruses, you're just assuming that they've been co-opted because it doesn't fit the evolutionary theory, but it hasn't actually been demonstrated. And I'm saying that the trajectory of discovery does favor genome-wide functionality because every single month, more and more papers come out suggesting more and more function.
You're okay. First, I'm going to make a quick analogy. If I come out and I say, horses are the most important mode of travel, that's just what they are. And you say, well, no, that can't be so. And I say, yeah, look at the Amish. They can't get around without horses. And then you say, well, no, because mostly people get around in cars. And then I say, no, it's really, really important in this one particular case that the Amish use horses. Are you getting what I'm saying? Case. These functional ERVs have indeed been co-opted. And the way that we know that they've been co-opted, other than the fact that they look very much like ancient viruses just in structure, when we look at them genomically, is the fact that the vast majority don't do anything. And when you say things like, well, the trajectory looks like, that's a very vague statement, because the fact of the matter is your talk with CRISPR was at least a year ago? And I checked today and they capped it right where he said they were going to cap it. He said upper limit, I think he might have said 20%. So he was a little off. He said upper limit, no more than 20%.
Right.
2017, upper limit 25%. And real quick, I'll pull something up for you.
I'm actually happy that you've at least admitted to that, because I even debated a biologist, I think it was 2 weeks ago, and I've debated like T-jump, for example. And every time I ask that question, right, how much of our genome, both non-coding DNA and protein coding DNA, do you believe the evidence suggests is functional? And you just said it there, just like CRISPR said, it can't be any more than 20%, 25%. But the thing is, that's because any more than that makes that type of fish to fisherman evolution impossible, simply based on mutation accumulation. Well, I've got a paper here that suggests that the genome has to be under 20% functional, or else ape-to-man evolution could not. Well, actually, actually, real quick before we go on too many rabbit trails, because I still want to touch on ENCODE, because a few things that you said I disagree with. Are you disagreeing with the fact that we do see massive amounts of literature nearly every single month that gives us unexpected functions of RNA? And then as you answer that too, how much of our genetics, of our genome, do you believe we've functionally tested according to the gold standard of genome testing? Go ahead, take your time.
So first, we can swap papers in a moment, because I've definitely, I straight up sat down today. I sat my butt down on Google Scholar and I combed for all literature that I could find that was recent on functional DNA. And the most cited paper, the most seemingly sort of groundbreaking biggie that came out this paper in 2017. Now, of course, we're always discovering new things about genetics. And of course, some of those things are new functions. But again, this conversation you had with CRISPR was at least a year ago. And
Right.
we have discovered we haven't passed the cap. We haven't even gotten close to passing the cap that he set. These guys are saying, and I'm going to read this to you instead of sharing my screen, just because it's annoying for everybody I know, and it causes a delay.
Well, real quick
But
before you do that, can you just answer the question as to how much of our genome has been functionally tested? Because that's important in this discussion. Because whether it's been a year or two,
I'm going to respond to that with the same sort of rhetoric back and forth that you and CRISPR had. So humans are mammals, and that's why we use mice and that for testing and things like that, our drugs and sort of pharmaceuticals. And that's why our pharmaceuticals tend to work so well, because we share so much in common. We have done extensive knockout tests on mice. We can knock out so much of their genome and they will be just fine. They reproduce, they have babies, their babies are just fine. So that's because that section that we're knocking out is non-functional. It doesn't harm them to knock it out. So, because I know this ENCODE conversation is going to go down maybe the non-coding or the non-functional quote unquote DNA is actually for development. That debunks it right there. The fact that these mice with enormous portions of their non-functional DNA knocked out can go and reproduce just fine. They might have a couple of weird little morphologies, but other than that, their fitness is increased.
Before you go on for too long with the mice, the problem is many non-coding RNA genes, even pseudogenes, for example, much of the non-coding regions of our genome, they're only expressed under certain conditions. And much of the genome is likely involved, for example, and used between conception and birth. And the fact that many of these non-coding sections of our genome are only expressed under certain conditions, you'd need almost unlimited sensitivity in these genetic knockout tests being done on mice to conclude with any type of certainty that those genes being knocked out really are non-functional. Because if these genes are being turned on and off, let's say after the developmental stage, or just based on environmental conditions during the life of the mice, especially because these mice, the genes are being knocked out in the laboratory. Therefore, many different environmental conditions that are outside of the laboratory, that a certain gene that isn't expressed and it's being knocked out, well, you're not going to be able to know that it's functional or non-functional. And the answer to your question, based on genetic knockout tests, especially with humans, because it's unethical, it's less than 1% of the genome that's actually been functionally tested according to the gold standard of science. So I even asked that question question to CRISPR, and he went on looking for a paper to show how many of these experiments were performed based on these genes that are only expressed under certain conditions, and he never came back with the specifics on that. So you'd have to show that. I don't believe that those types of knockout experiments on mice have been performed.
To be fair, in that conversation, while he was looking, you were like, you can just get into me later. So there is always the possibility, as I frequently do, that he just forgot to send them to you. Now, I obviously have not,
and that's fine. And that's fine.
Yeah, and that's fine. But I feel like you kind of obfuscated the point there, because again, for everybody who's watching, right? These knockout tests have been done on adult mice, or rather the impacts are on adults. They reproduce, They pass those knocked out genes to their offspring, who develop just fine, and then reproduce themselves after living their merry mice life. So the point is that if you're suggesting that there is no plausible way that I can see to suggest that genes that have been knocked out, even though we've done it on enormous portions, are secretly doing some kind of function when nothing bad happens when you turn them off completely.
Well, no, I'm not saying something.
Already broken
breakers. I'm not saying. Well, just to be sure that Erica's finished here, because you talked for a long time, and I want to just be sure Erica gets plenty.
It's all right.
You got it.
Well, I'm not saying that I'm not using a pseudoscientific argument suggesting that many non-coding RNA genes are only expressed under certain conditions. I mean, this is actually a fact. And my main point regarding that is we have only begun to discover just how functional, for one, the human genome is, and how functional the mice genome is. And I'm saying it's mind-boggling how many experiments, and I'm not saying it's impossible, but these number of experiments have not yet been done, and that's a fact.
And it's not, though, because knockouts have happened, and the mice still reproduce.
But the amount of experiments that would be required to conclude, is my point, with any level of confidence that a particular set of DNA sequences has absolutely no function, is mind-boggling. And
but the amount of experiments that you would have to do to conclude anything without beyond a shadow of a doubt is astronomical. The point is that the fact that you can knock out enormous portions of a mouse, and then the mouse can reproduce, and then its offspring can also reproduce because nothing of merit has been lost, is parsimonious only with evolutionary theory, that's what I'm saying. To use your word from earlier, the trajectory indicates that enormous portions of the genome can indeed be knocked out because they don't do anything. So, and I want to segue this in because
I didn't say that they don't do anything. I'm saying a lot of those regions in the because the non-coding DNA, it functions much like a computer. Okay, it's involved in regulatory functions. It's involved in embryonic development. It's even involved in the stagings of proteins for.
But they can't regulate if they're off.
But I'm
if
saying
you knock them out, they can't do anything.
No, but if these specific genes, and we have to look at which ones, what types of developmental windows, which types of environmental conditions, because if these experiments are being done strictly in the lab on these mice, well, these non-coding RNA genes, for example, even some of the pseudo genes, you're going to knock that out. You're going to snip it out, and it might not have some overall effect on genotype or phenotype, but that's because it's just not expressed.
Yeah, so but we're not talking about.
Just real quick, if you consider that, and then you consider, if you look at comprehensive knockout experiments for humans, for example, it's unethical, obviously, at this point. We functionally tested, genetics-wise, under 1% of the genome when you consider non-coding DNA and coding protein coding DNA. But the thing is, and the question I asked you earlier regarding the RNA, we do see massive amounts of literature that gives us unexpected functions of RNA. For example, are you familiar with protein moonlighting? Because
yes,
in the past,
of course.
Right. In the past, one of the ideas, you can just pick up a textbook from 40, 50 years ago.
One gene, one function, or protein, one function. Yes, I'm with you. Continue.
Exactly. Now, if we're looking at the protein multifunctionality, or we're looking at, say, on an amino acid level, these redundant codons, and I'm sure you've heard me say this before, those were always assumed to be absolutely neutral. Now we know they don't just tolerate error in the cell. These redundant elements, they're used to slow and speed the process. So the level of information compression into every single letter boggles the mind. It's actually incredible. And even
I'm sure that is indeed the case, but that's not the problem that I have with your statement that and in this conversation and in previous ones, that the majority of the genome is functional. The fact of the matter is, if you knock it out, it doesn't work. It doesn't do anything. If it doesn't do anything before you knock it out, there's no harm, no foul, right? So the fact of the matter is, if they do something important, anything, regulation, whatever, it doesn't matter. If they have a job that's even minute, if you knock it out, that job doesn't get done.
How much of the mice genome has been knocked out, though, on a percentage wise?
Oh, I could not give you a number on that. If you
well, I could, and I could be corrected on this, but the last time I checked, it is less than 30%. So based on the fact that these tests are being done in the lab, based on the fact that less than 30% of the mice genome has been knocked out, and the fact that, as I've said about 3 or 4 times, many non-coding RNA genes are only expressed under certain conditions, less than 1% of the mice genome, the human genome, mammals in general, has been tested for genome functionality. And all you have to look at, like I talked about earlier, you just have to look at the history of genetics. Like you said, back in the 40s, 1 gene, 1 protein, 1 function. I've said that multiple times. You can see how many things have been changed. So yeah, I agree that the results from the ENCODE project, Erica, I do agree that based on their suggestion that at least 80% of the genome is functional biochemically, right? Because it's showing that the non-coding DNA is transcribed into RNA. Those are preliminary. I agree with that. But I'm saying the trajectory is clear based on genome testing, based on the history of genetics, that the trajectory does suggest most non-coding DNA in the human genome is functional. At least it serves in a regulatory capacity. I mean, do you actually stand by a genome of only 20% max functionality?
Here's the thing, Standing. I go by current literature. And what I try to do when I don't know something about a topic is I check the most recent literature, I see how many times it's been cited, and I see who's on the paper and investigate their background. Because that's, it's just like what they teach you. It's appropriate sourcing. And I'm going to read you this excerpt. It's quite short from this 2017 paper, which was New Limits to Functional Portion of Human Genome Reported. An evolutionary biologist at the University of Houston has published new calculations that indicate no more than 25% of the human genome is functional. This is a stark contrast to the suggestions made by the scientist with the ENCODE project that as much as 80% of the genome was indeed functional. They took a deceptively simple approach, basically, to sort of sussing this out by looking at deleterious mutation rates and replacement fertility rate, which is quite odd, and I wouldn't have thought to do it, but I'm also not a geneticist and that's not really my world. But this is the quote that I think is important. This is from the paper. It's Grauer et al. If you want to look it up.
I've got that in front of me.
Or I can send it to you, yeah, too.
I have it in front of me.
Oh, good. Okay. For 80% of the human genome to be functional, each couple in the world would have to beget an average of 15 children, and all but 2 would have to die or fail to reproduce, he wrote. If we use the upper bound for the deleterious mutation rate, which is at 2 × 10⁸ mutations per nucleotide per generation, then the number of children that each couple would have to maintain a constant population size would exceed the number of stars in the visible universe by an order, or by 10 orders rather, of magnitude. So this is the most recent literature. Not only does it say, yeah, probably no more than 25%, they're saying it's impossible. So that is evidence that precludes, it's just using math, deleterious mutations and reproductive rates, replacement rates and things like that. And it directly precludes what you just said about trajectory. Because like you said, these papers come out every day. And every time the new DNA that they find that's functional, the new portion of the genome, gets smaller and smaller and smaller. They might say, oh, wow, we found out that 0.15% of this, given portion is functional. Add it to the list, but it's sort of exponential. There's not that much more to kind of sort of complete what we know, at least about the proportion of what is and what isn't functional. I encourage you to read the paper because I'm not a genetics person, but I found it quite easy to understand. And the math is pretty straightforward.
Right. So I appreciate that response. So in that paper, what Gore says, he says that human evolution would be very problematic if the genome was 10% functional, but would be completely impossible if 25% or more was functional. So what he's demonstrating here is what results from an evolutionary mindset, because he knows, based on the possible functionality of the genome, if we look at mutations, if we look at what's inherited, mutation accumulation in general, it would make that type of ape to man evolution impossible, because of the fact that if you have a genome that is, say, 50% functional, 60% functional, well, that means these so-called neutral mutations that supposedly build up with no real effect on phenotype and genotype would actually be more so nearly neutral.
Right.
That
so
means,
you're saying there's a heavy bias, is what you're saying.
I'm saying there's a heavy bias, and you can even see that with the ENCODE researchers themselves. You can see that they did their research without that evolutionary bias. And evolutionists, like the author here in this paper, they would have to fight the results of ENCODE. They would have to fight any type of trajectory that suggests the genome is any more than 20 or 25% functional, based on the accumulation of mutations. Because, for example, Komura's theory of neutral mutations, right? Neutral mutations build up. Those neutral mutations are used over time by organisms to change, to adapt, to modify. But
well, Komura, come on, Komura was taken greatly out of context. I looked into that as well, with Jameson or Tompkins, I can't remember which one. But I want to make a very short, brief comment.
A real quick before you do go on to that, and you take as much time as you need. The point that I'm making here is, obviously I disagree with the idea, or with the belief that the genome is 20% functional or 25% non-functional, or functional max. Because, and even if I were to just say concede that, or just choose to agree to disagree, even if, though, 90% of the genome is perfectly neutral junk DNA, say only 10% of it is functional, that's still a huge problem, because based on what we know about the human mutation rate, right? We accumulate 100 new mutations per person per generation. That means, Erica, if I were to just agree with what you're saying, about 10 harmful mutations are still arising in every person, every generation. That means even the most fit individuals are still more mutant than their parents. And so even with intense selection, if we're looking at natural selection here, against the less fit, it cannot stop mutation accumulation. But like that paper suggests, the more functional the genome is, the more of a problem genetic degeneration becomes. Okay, take as much time as you need.
Yes. So here's the thing, and I'm going to use this to segue into genetic entropy, because I feel like that's kind of where you're, pulling a little bit, which is fine, because I got my notes right here, because I don't know enough about genetics just off the top of my head, give at least numbers. But I want to make a quick comment about bias. Now, in the social sciences, anything that many areas of science that require an interpretation of the data, bias can be problematic. Here's where bias can't be problematic: with math. When you're just doing equations based off of either known rates or variable rates or whatever, as long as you've got your error bars, they're going to cover your bias. That's what they're there for, to say, okay, well, it's give or take, right? So you can say, yeah, he's biased to evolution, so's the vast majority of science. And I would agree with you, because I am also biased towards evolutionary theory, but it doesn't matter, because all he did was use math to get his point across. He plugged in equations. So you can say I disagree with it, but that's the same thing as being like, I disagree with if whatever, the Pythagorean theorem or something like that, just like an equation. Now, if you went in and you discovered, I guess that's a bad example, if I showed you an equation and you were like, I disagree with it. Now, if you go in there and you find an actual problem with it, that's another story. But as far as bias goes, it's not problematic when you're dealing with mathematics or physics or things like that. Or at least it's far less of a problem, because there's less room for interpretation. Now, as far as genetic entropy goes, it's not real. Genetic entropy, or at least the conventional science term, is error catastrophe. And it doesn't happen for several reasons. If you've got go ahead and give me. I want to make sure that I'm kind of addressing the proper point, so I don't go on a big spiel and then we're talking about something different. When you talk about genetic entropy, are you talking about the accumulation of near neutral mutations that causes degeneration?
I would say if you look at genetic entropy or genetic degeneration, for example, it is the fact that natural selection cannot stop the accumulation of most harmful mutations. The problem is that the human mutation rate, for example, it is widely accepted to be 100 new mutations per person per generation. Now, even if I were to agree to disagree on your point or assertion that, you know, max functionality of the genome is, say, 20%, 25%, even though I want to make one last point about the function of the genome anyways, I would say that it is a fact that ENCODE, which you were referring to earlier, it does at least show that most of the human genome is functional, but also functional on many layers. Like, we literally have layer upon layer upon layer of programming, Erica, within the genome. And no computer program has ever been seen to arise by trial and error or by chance. But genetic entropy would suggest that these mutations that evolutionists are saying drive the evolutionary process are either nearly neutral, which are slightly deleterious to the genetics, or detrimental. And that's the problem, is what type of selection is going to be able to filter out all those bad mutations, whether nearly neutral or just detrimental. Go ahead.
So the thing about ENCODE, again, just to give my, I guess, final point on it, for those of you who are watching, one, the definition of functionality is incredibly loose. And if you watch Stanning's conversation with CRISPR, who is has sort of hands in many different fields. He knows quite a few people who are, he's a cancer guy himself, but he knows quite a few people working in various areas of bioinformatics and things like that. And his conclusion was that he could maybe find 2 people out of the dozens upon dozens upon dozens that he works with who would agree that the definition of functionality was even remotely appropriate, because their definition of functionality covers everything. And the reason is because that's how you sell a project. I've been trying to sell my project for grants, because I'm doing a master's program right now, for several weeks, and you have to make it sound good or else you don't get the funding. So, and that I'm not saying that like it's anecdotal. That's how it is. That's it. That's just academia.
And just for the record, I'm not disagreeing with the definition that ENCODE used and the definition that CRISPR says that they use, right? Because ENCODE defined function as specific biochemical activity. And that's why I agree with you that the results suggesting that over 80% of the genome is actively transcribed into RNA is preliminary. That's why we've made a prediction as creationists that based on further genetic testing, knockout tests, for example, or testing mice under various types of environmental conditions where these non-coding RNA genes can be expressed in various ways is functional. That's our future prediction. And I think
yes, of course. And my answer to that would be ENCODE has already been busted by this 2017 paper. And I think there was another one in 2016, maybe, but I picked the most recent one because that good practice, I suppose.
Do you know how many, I think this is an important question before you move on. Do you know how many cell types ENCODE tested?
Oh, no, I don't.
Well, here's the problem. Here's the problem. So based on what ENCODE discovered regarding the function of our DNA, I understand that they defined it as specific biochemical activity. We have more than 1,000, and I'm sure you already know this, we have more than 1,000 cell types. So I'm saying, and I'm saying this to you in the audience and to James, the moderator, I'm saying that more function is going to be discovered in the future. Because if you're testing only 200 cell types and we have over 1,000 cell types in our genetics, I think it's just based on an evolutionary bias to say that max functionality of our genome is 20 or 25%. And I know that the reason why he concluded that in the paper is based on mutation accumulation. Because if it's any more than that, mutation accumulation makes ape to man evolution impossible. That's a fact.
The problem though is that I don't know, excuse me, I'm not sure for certain where you're getting your mutation rates from. I have a hunch that it's Jensen's rates, or at least Kimura, the people that Jensen sort of pulled from. And if I'm correct on that, which I don't know that I am.
Are you saying the 100? Are you saying the 100 new mutations per person per generation? I mean, you could find that all over the place.
Whichever mitochondrial rate, mutation rate, and nuclear mutation rate that he uses to make the case in replacing Darwin. Am I correct on that or no?
No, well, right now, I mean, if you want to get into replacing Darwin and the created heterozygosity hypothesis and mitochondrial DNA mutation rates and stuff, I mean, that's a totally different topic than
all I'm asking is it the same mutation rate that Jensen uses that you're using to say it over 25%, or not over 25%, but the deleterious mutation buildup would make ape to man evolution impossible?
No, that's just secular literature. I mean, the human mutation rate is generally known to be 60 to 100 new mutations per person per generation. I believe that's on trio studies.
Yeah, I was mostly just curious because there are potentially infinite problems with the way that Jensen did his methodology.
Right, and we can go into that, but that's a totally different topic.
That's why I was just checking. It's up to you. We can talk about genetic entropy, or we can talk about the LMN haplogroups. Whatever you want to talk about, I'm good to talk about it. My closing thoughts are, I think that you got to look to the current literature, and I think that it was handily proven exclusively with math that there is a 25% cap.
We are coming. Hold on one sec. We are coming to the closing of the open discussion pretty quick here. So let's see. We had standing start, and so if you want to do one quick rebuttal, hold on 1 second.
Discussion-wise,
it's been about 50 minutes.
Well, can we bump it to 60 minutes so we can touch on just a couple more things here, or it's up to you? I know it's getting late for Erica.
I don't have a preference. It's up to you guys. I can stay up 10 minutes later.
That 50 minutes went by fast, Erica. I think we could go at this all night.
I think what we can do is, if we want to, how about we do this? Instead of an extra 10 or 15 minutes, if we want to just standing for truth, we can give you another round to kind of make your points, and then we'll give Erica one more round to make her points, and each of those being just a few minutes.
That's fine.
Should we do a couple more minutes of back and forth, and then, because that kind of sounds like it would be like almost like a concluding statement if we're just going to go a few minutes uninterrupted. I mean, whatever you guys think is best.
Yeah, so that's right. You had heard right. So we'll just have it be like a few minutes kind of making your points, and then we'll give
Sneaky
Erica a chance to make her few points, and then we'll wrap it up.
Okay, who wants to start then their few minutes final points?
As I just said, given that you were about to start, like, you can now start, and then
Okay, so I think since what we were kind of heading into there is genetic entropy, you can answer the question as to, what type of selection is going to be able to filter out all the bad mutations, because the major issue is the fact that selection, it can amplify the best beneficial mutations and it can get rid of the worst detrimental mutations, but it's pretty well powerless to the nearly neutral mutations. Those are invisible to natural selection. I mean, you could think of it this way, Erica. I mean, we've got a genome of 3 billion letters. 3 billion are passed on from mom, 3 billion passed on from dad. But if you take out one letter, say change one letter randomly, are you going to have a huge fitness effect? No, it's going to have a tiny fitness effect. It's kind of like rust on a car. You can't see each rust event, but it's continuous and destructive. Or like a single spelling mistake in a book the size of an encyclopedia, right? Make one single spelling mistake. It's not going to have a huge overall effect, but the accumulation of them over time, yeah, that's going to destroy the message and the book. But why can't natural selection filter out all the bad mutations, Erica? There's two reasons here that you'll have to address. There are too many bad mutations continuously pouring into the population, and most bad mutations are too subtle, as I talked about earlier, to be selectively removed. And we see genetic entropy in real time. Alzheimer's disease, dementia, autism clearly has a genetic component to it. Asthma, autoimmune diseases, cancers, what is it, 1 in 3 now? Immunological disorders, diseases. I mean, there is a pandemic. It's pretty well entropic degeneration on all levels. And the 100 mutations per person per generation is a fact. And you're going to have to address how that accumulation of mutations is going to be rid of in our genetics, because I mean that's what we see. We see genes are going down and not up. And if fish to fisherman is true, I mean, you're going to have to explain the major problem, which is a net gain versus a net loss of information. So, I mean, if you want to kind of address those points and give me your thoughts on genetic entropy and what your best argument is against genetic entropy, I guess that would be a good way to proceed.
Okay. So genetic entropy does not happen. The ecological term, again, is error catastrophe. And the reason why it doesn't happen, even though ecologists who have no affiliation with creation, evolution, anything along those lines, have tried to induce error catastrophe and have failed time and time again. They've done it with E. coli, they've done it with phages. It doesn't work. And the reason they do it with those is because they accumulate mutations way faster than sort of macroscopic life. So they can see if deleterious mutations are going to build up in a rather short amount of time. And here's the reason why they don't. Near neutral mutations, if they're near neutral and sort of beneficial, then they're going to be slightly selected for. Selection isn't an all or nothing thing, right? Let's say you have a near neutral mutation that is sort of a negative, right? It might not kill you, but it might decrease your fitness, because if it is a negative trait, right? If it is a bad mutation, by definition, it's decreasing your fitness. So you're going to reproduce less than your peers, and whatever offspring that you do manage to produce will reproduce less than their peers, and they will continue to pass on that sort of slightly bad mutation until eventually it is eradicated from the population by one reason or another. It might simply be missed reproductive opportunity. So if it is even remotely bad, selection acts against it. That's just how it is. If it's neutral, and when I say neutral, I mean truly neutral, they can accumulate all they want. Nothing's going to happen. There's nothing to select against. That's the definition of something that is neutral. There is no good or bad kind of impact to it. Now, what you might have in sort of your best case scenario is if an entire group of organisms all get bad mutations at the same time. And as they build up upon one another, they sort of have I think it's epistatic sort of an impact on where they build up, and it makes them subsequently worse when they combine with one another. But the problem with that is the definition of genetic entropy and of error catastrophe means that it has to accumulate across generations. Regardless of whether it's epistatic or not, the negative mutation will hit the second, and negative selection against sort of this trait will happen the second fitness is reduced. One way or another, that's happening in one generation. So there is no plausible way to suggest that error catastrophe or genetic entropy can occur, because it is the accumulation of bad mutations across generations that eventually harm fitness. We don't see that. Ecologists have tried understanding error catastrophe, because cancers and things like that aren't error catastrophe. They're similar in ways, but again, it's not cross-generational. So understanding it would be quite helpful for fighting those diseases, but they can't do it because it's not a phenomenon that occurs. Sanford, I believe, claims it happened with H1N1, but I read that paper. Not only is it a bad paper that actually makes several mistakes, but it swaps its definition of error catastrophe around whenever convenient. So essentially, my answer to your question is there is no such thing as genetic entropy. We don't see it naturally. We don't see it in a lab, even though we've tried. At least the definition that creationists give. So it's not a problem because it's not real. That's all I got to say about it.
Thank you very much. And standing for truth, I know that you have another round in the barrel. But just for the sake of giving, we
too well, James.
We can always do the tiebreaker debate. We can do an end game debate. We should call them that from now on.
That
like
is a good idea.
The trilogy end debate where we have like the final of 3. So we definitely can do that, but I do just want to make sure that Erica gets to sleep on a decent, hopefully at a decent time.
You're
so
sweet, James.
It's
I will
no
say
problem.
That conversation flew by. It was a lot of fun.
I
had a good time.
It's also because I'm tired. Now, next up, Steven Steen, thanks for your super chat. He says, standing for truth cannot be stopped. He's a beast. SpongeBob. You have a fan out there.
That is far too sweet of Steven to say. I obviously paid him to say that before the debate. If you could read a couple more super chats, I'm running upstairs for literally 30 seconds, James.
Deal. Steven Steen, that sicko, also says, James is the new Adam sent from God to fix us soy boys' flawed genes and restart the human race without flaw or weak jaws.
Listen, James, I have heard you are an alpha Chad. I've heard that from other people.
That's hilarious. An alpha Chad. I had never heard that before, but I like that. We'll call Steven Alpha Chad from now on. Let's see. Bent Hovend. No relation, it says in the name. Says Erica and Dapper Dino should debate standing for truth and Kent Hovend at the same time.
I'd be down for that.
That would be epic.
Be fun. Could be fun.
We actually, I forgot to mention. So we do actually, it's coming up quick. We do have, as you see in the bottom right, Kent Hovend will be returning. We got off on the wrong foot one day, and I will take responsibility for it. And long story short, for a while, it looks like we weren't going to have Kent Hovend on anymore. But Mark Drisdale convinced him. So you see Mark in the picture there. On the left side, he looks kind of like an action hero star, the bald head and the goatee. He has convinced Hovend to come back on. So that will be a good one. But
you don't want to get on Kent's bad side. He'll ban you from Dinosaur Adventureland.
That's true. So it's also Genesis and cosmology. A discussion will be going on this coming Monday with Skydive Phil, popular YouTuber, really really pleasant guy, and also Dr. Jeff Zwierink. So that's going to be a really fun one. That's one that we've had planned on 2 different dates because I don't know what was wrong with me. It's the first time I had ever wondered, like, oh my gosh, really wondered. Is there something wrong with me? Like, because I really thought, so they contacted me, they called me, they're like, James, it's not today. And I was like, oh no, you're right. So long story short, glad you're back standing for truth. I could hear
You've only wondered that once. I wonder that every day.
Yes.
About myself.
Well, thank you. I appreciate that. And standing for truth, I think I could hear you cackling in the back. You must be back.
I'm back, my friend.
Gotcha. Thanks so much. So
wanted to make myself known.
You betcha. Let's see. Michael Dresden with his normal trollish super chat says, I'll save you all the time. Evolution is a myth. You can respond to that, Erica, or you can not dignify it and ignore it.
I'll respond. You're wrong.
Gotcha.
Yeah.
It's short and pithy. I like it. Speed of sound of gravity. Who says, by the way, he said that he or she said, standing for truth, you are afraid to debate them. So they said, standing for truth, buck, bagok.
Buck, bagok. Like, you know.
Okay,
yeah, Speed of Sound sends his regards standing. He says he wants a rematch, so.
Okay, so, and that's funny, Erica mentions that. So I've had 2 debates with Speed of Sound. So definitely over 2 hours, maybe 2.5 hours of dialogue. We debated the same topic that Eric and I just debated, and a topic specific to chromosome 2 fusion. So I recommend anybody go look at those debates. I suspect he only wants another debate because of something called damage control. He knows he lost, but you know what, Mike? Maybe one day. I'm going after the big dogs now, though.
Very sassy.
That's what they call me.
That's right. Jay Shy, thanks for your super chat, said, what if there were people outside the garden whom evolved, then mated with Adam's descendants, still making Adam and Eve our genealogical ancestor? Cain hints to other people who might kill him. So standing for truth.
Right. Well, I would say that we don't even need to go that far, because the Bible tells us we came from just two people, Adam and Eve, of course. And if you just look at my opening, I went over the fact that we've got these pieces of DNA, for example, the Y chromosome DNA. The Y chromosome we only get from our fathers. And it's passed on unbroken from father to son, and every once in a while a mistake happens, and every time this happens a new branch in the family tree is formed. So all we have to do is look at all the branches in the world, James. They go back to a single person, not to a chimpanzee, okay? And that's what this debate was, limited ancestry versus universal common ancestry, but to a man who lived just a few thousand years ago. And the same thing goes with mitochondrial Eve. So we can just believe the Bible. And when we start with the Bible as it's just plainly understood, we can make accurate predictions and retrodictions.
Gotcha. Thank you very
James,
much.
if I can make a recommendation for some reading for that individual, they should check out John Walton's series, because he actually subscribes precisely to that, what the question asker was talking about, sort of like a theistic evolution type thing. I've read some of his work. He's an academic. He seriously knows what he's talking about. I'd give it a look. It's pretty interesting stuff.
Gotcha. Thanks so much. And next up, Stupid Whore Energy, as she likes to call herself. Very sick. She says,
I haven't heard from her in a while.
That's right. She says, new genes can arise from non-coding sequences. That's why orphans are not a problem.
Right. So it's just as I iterated earlier. It's called de novo gene synthesis. And I don't want to beat a dead horse, but just go back and watch the discussion. It is a circular-based argument. It's never been observed that these non-functional, non-coding DNA regions are suddenly co-opted to have an important functional role. But orphan genes in general, they are taxonomically restricted. They are functional, and they do suggest, along with many other lines of evidence, that limited ancestry is true, because there's so many lines of evidence that the evolutionists have a major problem explaining, other than weak rescue devices, in my opinion.
Gotcha. Very sassy. Go ahead.
As a question sort of for standing, what do you make of all the astrological phenomena that we draw ties to despite never having actually laid eyes on them in person, like black hole physics or supernova or novae, I guess, neutron stars, things like that? We just get data, we just get readings, and we formulate entire hypotheses about them that then are confirmed by other data that we receive. So you don't have to be a direct observer of something to know that it happened. You can see the aftermath and get the same idea. That's where a lot of science goes. Anyways, that's just an anecdote.
I agree. I mean, you can have all types of hypotheses, but those hypotheses have to have supporting evidence. The evidence has to be demonstrable. It has to be empirical. So some of the things you just mentioned are demonstrable, and the inferences that are made are based on really tight scientific-based evidence. But when it comes to like the Y chromosome dissimilarity between chimps and humans, or
we didn't get to talk about that, and I researched that this time, and I was ready for that. We didn't get to talk about it. Dang, well, remember, we didn't get to talk about a lot of stuff.
Well, remember, round 3, Endgame, Avengers style.
Listen, eventually I want an Age of the Earth conversation, okay? Or we can talk about anthropology again. I don't like being out of my element.
I enjoyed the human evolution debate, and now we did one on this topic. So yeah, maybe the next one can be Age of the Earth related, or looking forward to it, put it that way.
Very juicy. Mike Billers, thanks for your super chat. They ask, can Standing for Truth re-explain Erica's explanation for orphan genes and maybe stop using it in the future since it's explained?
Well, I know the answer to orphan genes that is given, because it is a major problem to evolutionist theory, is de novo gene synthesis. I can't remember if that's the argument that Erica used. She I guess looked to endogenous retroviruses, for example, and the functions that are now been found in these so-called ancient viral elements have been co-opted. it just comes down to the fact that, are these anything more than just stories, rescue devices? So I understand the arguments put forth by the evolutionists. I just don't see them as being very convincing.
Gotcha. Thanks very much. Moving quickly, Josiah Hansen, thanks for your super chat, asked, Erica, protect your hand when giving such a spanking. Very nice. Gotcha. Excellent. Let's see. Next up, thanks for your super chat from Florida Man Edo Hypnotoad Evangelist. Appreciate it.
Oh, blessings on you.
Gotcha. Thank you very much. Let's see. They're asking, give me 1 second. They asked, why can't creation answer the phylogeny challenge?
I'm guessing that question's for me. Yep. I would say that the phylogeny challenge is fallacious, because it all comes down to, where can we draw the line regarding ancestry? Where can we, where does that phylogeny break down? But the thing is, that entire argument misunderstands biology and genetics, because and theology, because they seem to imagine that God created humans and then all of other biological life, and that there's absolutely no similarity between humans and any other species out there. So based on the biblical model, there's really no reason for us to believe that that's true, as in, there should be no type of hierarchy in the biological world. As in, there's no reason to believe that we shouldn't be more similar to, say, apes than to another species, say a whale, right? So we too predict nested hierarchies in biology, whether it's on an anatomical level, physiological, morphological nested hierarchies. So that's why I always say we need to look to differentiating kinds of evidence to show which explanation, limited ancestry or universal ancestry, is true. And that's where we can get into function. We can get into Y chromosome, mitochondrial DNA predictions. This is how we're going to truly answer the question of ancestry. So long story short, the phylogeny challenge it's fallacious, and it's based on a misunderstanding of science and theology.
Gotcha.
Hey James, can I answer this one too? But just from my side.
You bet.
I think the best question that the question that I have for creationists on this one, of course, it has to do with primates, because I love primates and I am a primate. But frequently creationists lump all the apes into an ape kind. And my question kind of runs along those lines, because frequently a kind is described as things that bring forth, organisms that can bring forth with one another. But chimpanzees obviously can't reproduce with gorillas or orangs, or, well, they can with bonobos, but they're actually very recent divergence. And there's been slightly disturbing, but a bit of sort of theoretical research looking into how reproductively compatible humans would be with chimpanzees. And it's more than it is with gorillas, and it's not actually been considered to be impossible, as terrible as that sounds. It's simply a ring around the egg, the zona pellucida, that sort of gate checks any spermatozoans or sperm in general that try to come in. So reproductive isolation is kind of a bad way of drawing the line, which is why I always ask why and how we draw it. And that's why I don't think they can answer the challenge, because there is no way to draw a line. Genetics is a gradient, and it runs through all living things. And that's why paternity tests work. And that's why, genomic comparisons work.
Well, if I could make just one quick point.
Really,
if you just think about it, Erica, okay, according to our model, I'm just going to throw some, kinds out there, say humans, pigs, rats, ducks, and dogs. They're all land dwelling, okay? Even though they are separate kinds according to our model, since they are all land dwelling and share many similarities with each other, they can share similar nested hierarchies or designs. So where are we going to draw the line between those separate kinds if they already share certain levels of nested hierarchies, morphologically speaking, genetically speaking, physiologically, speaking. So that's the thing.
But that's a fancy way of saying you can't draw the line. That's a fancy way of obfuscating that the line can't be drawn. And if your model is correct, then the line should be able to be drawn, because it is, I mean, of all the things in Genesis that are like Genesis 1 that are like super clear, there's quite a bit of emphasis on the kinds. It's repeated over and over and over again. You would think it would be quite obvious.
Well, even though we predict nested hierarchies, evolutionists, when they say that there's this perfect nested hierarchy, there's this perfect phylogenetic tree of life, that's not actually true, because anytime there's an inconsistency, Erica, and say a lack of uniqueness in that phylogenetic tree, as you know, it's usually explained away by what? Convergent evolution. So that's a rescue device. There's also something called independent lineage sorting. If you look at different genes in, say, humans or apes or gorillas or orangutans, depending on the gene you're looking, can create a totally different type of phylogenetic tree. So even though you're implying that there's this perfect nested hierarchy of life, that's not true. There's many, many types of inconsistencies I can point to.
Gotcha. Yeah, but the thing is the inconsistencies are, while present, they're present in every branch of science, from medicine to astronomy to, of course, evolutionary biology. That's the nature of the beast. The question is, how strong and how parsimonious are the lineages that we do have these straight through lines? And the answer is incredibly. I know primates the best. It's undeniable from my position. I mean, but that's just me.
We have to standing for truth. I'm sorry, but just to get through more questions, we have to jump through.
That could have been debate number 3.
Yes. Dapper Dino, thanks for your question. Asking to both, are you familiar with the observed de novo emergence in Drosophila or Saccharomyces?
Yeah, so the fruit flies, for example, read that paper. For one, it's done in the lab. It's also inferred. And what they've done in the lab is they've forced these orphan genes out of the genetics of these fruit flies. So he's trying to say that this is an example of de novo gene synthesis, when all it is an example of a loss of orphan genes, which can happen, obviously. So I want to see an example in real time, not in the lab, of de novo gene synthesis, and not just an example of an orphan gene being lost. I mean, that's just...
How would you even do that, though? How would you see the emergence of a de novo orphan gene not in the lab? You're not going to, I don't know, maybe you follow like a colony of Drosophila around with a net, and you catch them every couple minutes, and then you do some genomic sequencing to find out. I mean, I don't know how you would even go about doing that. It's an impossible experiment.
So are you admitting that it's never been seen?
No, it has in the lab, but you would just ask for it outside of the lab, so you can't do it outside.
It hasn't been seen in the lab. I just told you that all that was seen was the loss of orphan genes. That's not the gain of orphan genes, Erica.
Hold on, hold that thought. I'm not sure. Let me pull up this paper. James, pull up the next question, if you would, please.
Yes. Next up, thanks for your super chat, Pax Americana, asking, standing for truth, even early church fathers, such as St. Augustine, knew that Genesis wasn't a literal account of creation. YEC isn't even theologically sound.
Technically, if you look at what the plain reading of the Bible is, if you look at church fathers, quote unquote, throughout history, the majority of them did believe that the geology of the earth was explained by Noah's flood. Hans come to people evolution was not heard of. But the most important thing is we can just look at a plain reading of scripture, and we can see that God created Adam and Eve, and we can also make predictions and retrodictions. And the science tells us we come from a Y chromosome Adam, a mitochondrial Eve. The human species overall has low genetic diversity, which points directly to Adam and Eve. That's why the evolutionists had to resort to the out of Africa population bottleneck theory. I mean, Erica and I discussed that thoroughly in our previous debate, but a plain reading of Genesis clearly is consistent with empirical scientific data. So
look into the Toba catastrophe, if you would, Standing. That's one of the primary explanations for the bottleneck that there's quite a bit of evidence for.
Right, and I did, and it looks like there's no major consensus on whether or not this Toba volcanic eruption is resulted in the population bottlenecks. There's, I believe, some sides in science that believe there's some inconsistencies with that theory, while others hold to it. So, I mean, that just might be a discussion for another debate.
Yeah, I think that it's best explained with a combination of that and founder effect from populations leaving Africa. But that's just me.
Just to move through as fast as possible, Jay Shy, thanks for your super chat. They said, Francis Collins, a Christian, mapped out the human genome and is convinced of universal common descent. Why didn't this lead him to your conclusion? I think that he's asking Standing for Truth that.
So he looked at, actually, can you repeat that real quick?
They said, Francis Collins, a Christian, mapped out the human genome and is convinced of universal common descent. Why didn't this lead him to your conclusion, Standing for Truth?
Good question. So Francis Collins, I definitely recommend his book, The Language of God. The major arguments he looks to, for example, you'll see him speak of ancient repetitive elements, the non-functionality of our genome, shared genetic mistakes, for example. But he's had to actually go back on a lot of that because he's one of the scientists who has admitted that ENCODE has revealed that much more of the genome is functional, that the genome has many more functional DNA elements than previously thought. And even Richard Dawkins has had to go back on that. I mean, he's the one who quoted, and I don't have it right in front of me, that over 90% of our genome may as well not even be there, implying that most of it is useless. Yeah, Richard Dawkins, just go knock out that 90% of the genome. So it's just based on an evolutionary bias. But yeah, Francis Collins, I'd recommend reading his book, and all his best evidence for universal common ancestry has been completely overturned, just like the junk DNA paradigm has been overturned.
Gotcha.
Now, that 2017 paper disagrees with you, though, Standing. That one doesn't quite agree that 90% couldn't be knocked out if we're dealing with the 10 to 12 range, which is pretty typical. I'm sending you a paper, Standing. I think this is the one that was being discussed. Go ahead, James. Sorry.
Gotcha. And then, let's see. Kevin Tremblay, our friendly moderator, if you can do me a favor, and we usually only time people out or delete their messages if they are using hate speech. So even if they're abusive, like, please ask them, like, why they're being abusive towards somebody. But in other words, like, try to discourage them. But we usually try to only delete or ban people if they're engaging in hate speech. Next up, Mr. Archaeopteryx, Standing for Truth, an amoeba genome is 100 times bigger than a human's. Does an amoeba need 100 times more information, or is most of it non-functional?
Well, looking at an amoeba genome is a lot more different than, say, testing the genetics of mammals, humans specifically, which is where we're making the direct predictions. But organisms like amoebas, yeah, they are subject to whole genome duplications. Also redundancy, in a lot of these organisms that do have 2 or 3 or 4 times the amount of genetic content than, say, a human, may just need more redundancy for environmental conditions. So, I mean, epigenetics, environment all play a factor in our assessment of the genomes of all forms of life. So, yeah, amoebas, they are subject to whole genome duplication. So some of it could certainly be non-functional.
Hey,
Gotcha.
James,
Yep.
Real fast. For those of you who also want the paper that I just sent, Standing, it covers the orphan genes quite well. There's some excellent sources within it covering orphan gene emergence, which I believe, I didn't get a chance to read the entire thing, but it's sort of alluding to the fact that this has been observed in the lab. Not positive. Yeah. Don't quote me on that. Side note, I also had the chance to briefly look, hold on, pause. I'm pulling it up, look at my email, and I had a message from Call Me Emo, who brings up an excellent point. that I wanted to pose to Standing very briefly. I think it's if that's okay with you, James. It's very short.
Yes.
Yes, I've seen his argument, and we've rebutted.
Well, hold on. I'll ask you the question because it's quite short. He brings up an excellent point that I didn't even think of, but
so am I debating emo now too?
Well, I saw when I was sending.
Let me just Google some arguments against what you said. Okay, go ahead. Yeah, what's
listen, I just think it's a good point. It's not my point, so that's by far no, but I did think it was quite good. He brings up the fact that orphan genes, if even within kinds, vary wildly from species to species, which would support de novo origin far more than sort of a taxonomically restrained limited ancestry.
Well, he assumes that those orphan genes are found within kind. So, for example, you can find orphan genes that are taxonomically restricted to humans, gorillas, and chimps. But he's assuming that gorillas and chimps are of the same created kind. That might just indicate that they are 3 separate created kinds. And the paper that you posted on the fruit flies, for example, we have an article in our book, Ram and myself, debunking that. What they did technically was they forced adult males to reproduce with infant females to get rid of their orphan genes. So it's unrealistic in nature and therefore irrelevant to the entire argument. Because like I said earlier,
I hate to say it, but if you think that that's unrealistic in nature, I've got some bad news for you. There is a lot of weird sort of sexual crossings across adult juveniles in various instars with arthropods. Arthropods are extra weird. But yeah, it kind of busts up the point that you made previously, though, that because they're taxonomically restrained, they are the ones that dictate what a kind is or isn't. And that
I'm saying it's a line of evidence that can dictate what's created and what's not. And that can actually dictate to us that humans, chimpanzees, and gorillas are all of separate created kinds. But the thing is, orphan genes are very specific. For example, we have noticed that all taxonomic restrictive orphan genes in, say, felines or the dog family correlate perfectly with what I'm saying. So right here, we've identified a feline kind, a dog kind, a human kind, a chimp kind, and a gorilla kind. I mean,
but you want to talk about unrealistic. You're going to tell me that chimps, gorillas, and orangutans are separate kinds, but that every felid and every dog is within the same kind? That's wild, dude. That is like out of this world. The orangs and gorillas, really gorillas and chimps, diverged incredibly recently, even in evolutionary times.
Hold on one sec. We do Standing for Truth. It's got to be really short and pithy here. Standing for Truth.
Yeah, you can finish up, Standing. Sorry, I keep inciting things, James. I apologize.
I like interaction during the Q&A. It's fun. It's fun.
Okay, gotcha. Thanks so much. Next up, appreciate your question. Speed of sound of gravity asks, Standing for Truth, what H3K4ME1 in Tompkins graphs indicate?
Histone methylation signatures. It's indicative of active gene promoters in transcription. He's trying to stump me, but I would recommend going to watch my debate. He's really good in genetics, so I've enjoyed my debates with him, but I got to be honest, he didn't do quite well against me on chromosome 2. We discussed it for an hour. It was a good debate. He's even admitted in one of his hangouts with some evolutionists that he was blindsided by some of my arguments. So, kudos for him to trying, in trying to stump me there. But sorry, Speed of Sound, you failed, man. Big time.
Next up, appreciate your feistiness. Appreciate your question from Terry James, who says, if creationism, quote unquote, predicted nested hierarchies, would disproving nested hierarchies falsify creationism, or would you take this as evidence against evolution?
Well, like I said, there are inconsistencies with the phylogenetic tree of life. That's why they need to look to convergent evolution. For example, I mean, you can see evolutionists invoking convergent evolution, which shows that this so-called phylogenetic tree of life is not as, it doesn't flow as well as they say it does. Because you can even look at an example that at the top of my head, let's say whales, dolphins, and bats, for example, okay? they're the only mammals that have echolocation systems. And maybe Erica has an answer to this, I'm not sure. But on the basis of gross anatomy, the whales and dolphins, okay, they're classified closer to the cow and other ruminants than to the bats. But on the basis of their echolocation systems, they should belong with the bats. Now, it gets even worse for them because molecular analysis of the protein prestin puts whales and dolphins squarely
70% of women stated that
for anyone in the audience who doesn't know, prestin is a sound sensitive protein and it's essential for hearing in general. So it's just one of the mechanisms, hearing mechanisms of the echolocation system. So this plus other lines of evidence I can go into is strong evidence that the phylogenetic tree does not represent objective reality and it should falsify universal common descent. But we do predict both models some levels of nested hierarchies. So yeah, that's my answer.
Thank you very much. Sidrifeo Sarabia, thanks for your question. They asked, Erica, how does a random evolution process create symbiotic associations? How does nature, quote unquote, select anything to work with another being in ecosystems?
That is a fantastic question. And I think that is quite intuitive, because you would think that would be somewhat of a complicated process. But symbiosis has been happening from an evolutionary standpoint from the very beginning. I mean, we have the endosymbiote theory, or hypothesis rather, which is that quite a large cell sort of phaged another smaller cell, and that's how you get the mitochondria. But the truth is that it's close, loose associations that then have such a fitness benefit for these two organisms being in close proximity to one another that it actually becomes more beneficial for them to stick together than to stay apart. We've seen this recently in certain species of primate use, for instance, vervet monkeys. They can actually rely on the predator calls of starlings. Now, that has been a recent adaptation in many locations. Now, of course, it's location specific because symbiosis does take a long time, but that fitness benefit of being able to utilize a starling call to know whether a predator is around because they have a better vantage point has popped up somewhat, in the sort of distant past, and it's actually led to some really interesting conservation methods where they teach vervet monkeys how to respond to starling calls, and they actually spend more of their time kind of making their sleeping quarters near starling nests because of it. So that's basal symbiosis, but that's how it happens. It happens with loose associations that through time become cemented, and that's what I got to say about that.
Gotcha. Thanks so much. Appreciate it. And we do have another question from Stupid Whore Energy, who asks, she says, slightly deleterious mutations are responsible for neutral constructive evolution. I think that's for you, Standing for Truth.
Right. I'm glad she brought that up. I mean, that's exactly what I was iterating earlier in the debate. They assume these neutral mutations build up in the genome, and they're almost used as a reservoir for change in adaptation and in forward evolution. So that's based on an assumption. What we now know about the genome, and as Erica and I discussed during the debate, most random changes contradictory to the evolutionists are going to be deleterious. But even if, like I said, Erica, even if the 90% of the genome is perfectly neutral junk DNA, as Stupid Whore Energy is insinuating here, that means, and Erica didn't answer this problem, and I don't think anybody can, that means 10 harmful mutations are still arising in every person, every generation. So even the most fit individuals are still more mutant than their parents. And you can have any kind of selection all you want, and it's only going to amplify the best and get rid of the most detrimental, but we are going to degenerate.
Gotcha. Thank you very much. Just to keep moving, Mothra J Disco says, Standing for Truth, where does the SIMP gene come from?
The SIMP gene? If it's a like many genes, for example, if we look at allele frequencies, whether it's rare or common ones, they can arise, say, post-Babel, depending on their frequency in the. I'd have to know exactly what that SIMP gene does.
Gotcha.
I don't know. I'd have to have clarification. Do you know what that gene does, Erica?
New to me.
Again, to reiterate, genetics is not my field. I can speak with a decent amount of authority with primates and with human evolution. Genetics, that's why I had notes.
Yeah, I would say that the majority of our genome is created heterozygosity, but there are some alleles that have, there are some mutations. For example, blue eyes, that's based on a mutation, according to our model, post-Babel, post-flood. But we can determine that based on allele frequencies around the planet. So I'd have to know exactly what that does, if it's a mutation or if it's created. It's one of the two.
Gotcha. Appreciate it. Next up, appreciate your super chat from Jay Shy, who says, standing for truth forgets we have recombination.
Yep, recombination occurs, but recombination is no help to forward evolution. I mean, recombination and gene conversion, for example, those are a couple mechanisms that we look to in our created heterozygosity hypothesis. That's actually going to create diversity quickly, especially if the DNA differences are built in from the start. It's kind of like shuffling a deck of cards. I mean, you're going to have diversity in every single generation. That's why two people can technically have millions of children, and every single children are going to be different. No two children are going to be absolutely identical, and that's because they're heterozygous. And like I said in my opening, that would be optimal design. If you, that's all I have to say to that one.
Gotcha. Next up, thanks so much, Sigifredo Sarabia, who asks, Erica, is genome degeneration real? If no, what evidence can you give going against it? If yes, what evidence can you give that deterioration of ape DNA doesn't follow the same degeneration before evolving somehow?
So the problem with this concept of degeneration is that it depends entirely on what this individual is talking about. If this is a reference to degeneration, at least in the form of genetic entropy, the answer is selection always selects if it's not neutral. Even if it's partially bad or partially good, selection still occurs. It just might not occur as quickly. As far as variations in how selection works and other kind of genetic concepts like mutation and things like that, mutation is not constant. It's not constant in a single species through its lineage, and it's not constant further throughout into other species lineages either. Chimps have a 30% higher mutation rate than we do, and orangs and gorillas actually have a 40 to 50% faster mutation rate than us. So accumulations of any kind of mutation are going to vary depending on the species and depending on how far back they diverged. Now, again, I'm not 100% sure what they're asking with regard to genetic degeneration, but if it has anything to do with genetic entropy, there is no way natural selection doesn't select. It's not an entity. It's just literally response stimulus with the environment. There's no, people like to say that evolutionists use natural selection as like a god, but that has nothing to, that there's no, it doesn't follow. It's a non sequitur. Natural selection is simply how an organism interacts with its environment on a genotypic and a phenotypic level, and the changes that occur based on sort of a combination of chance and fitness.
Gotcha. Tioga.
Actually, if I could say something, I promise. I promise. Less than 5 words. Less than 5
I'll give you. Okay, less than 5 words. Go.
The problem is, that's 3. Natural selection acts on phenotype and not genotype, and I'll just leave it on that.
Tioga, thanks for your question or super chat. They said, I stan Erica, my biology queen, all in capital letters.
Oh my God, you've made it worth staying up this late. That is a lovely compliment.
Very nice. Subtracted, thanks for your super chat as well. They say, hey, standing for truth, if Adam and Eve didn't know they were naked, how was Adam aware that Eve came from his rib? Genesis 2:23, you need to be naked to see your ribs.
I'm going to have to think about that one. Obviously a theological based question, but how did Adam not know that Eve came from his rib? Didn't God put Adam to sleep when he took his rib, made Eve out of it? I don't know. I'd have to think about that one a bit.
Gotcha. Jay Shy, thanks for your super chat. They said X and Y Adam were separated between 30,000 years. So put that in your pipe and smoke it.
I was hoping, well, I figured we would get into the discussion on mitochondrial Eve and Y chromosome atom, but based on observed mutation rates, the empirical method, trio studies, for example, we can use pedigree-based studies. Adam and Eve only lived just 6,000 years ago, but evolutionists have to counter that by using unobserved and unrealistic mutation rates. So they don't use the empirical method when it comes to mutation rates. So realistically, you can look at the studies and look at how those dates are derived, and they're really heavily based on evolutionary assumptions. So
gotcha. Thanks so much. Almost there. Let's see. Sigilvados Arabia, thanks for your super chat. They said, standing for truth, is a platypus a kind of mammal or bird?
Or bird?
Yes.
Because of the bill, I guess.
I would say platypus defies evolution. I mean, what did the platypus evolve from? It looks to me like the platypus is of its own separately created kind. I know I'm not sure if there's a universal consensus as to the history and the ancestry of the platypus, but definitely not a bird kind.
Gotcha. Appreciate it. Next up, appreciate your super chat from Stupid Whore Energy. Strikes again. She says, 2 transposable elements in humans and chimps at the same genomic locus means the original insertion was in the ancestor because there are tens of thousands of possibilities for a TE to insert itself within large genomes.
Right. So these TEs, which as he iterated, stands for transposable elements, but they are an important source of highly regulated, they're biochemically active. They are non-coding elements, but they are important in transcription, factor binding sites, and in non-coding RNAs. So they are pervasive in the genome, but they're also functional. So based on their position and location, that's predicted based on our nested hierarchical expectation based on similarities and dissimilarities. But the fact that they're functional DNA elements, just like the endogenous retroviruses, the ALUs, that's exactly what we've predicted all along.
Gotcha. Appreciate it. Next up, Stupid or Energy. Thanks for your super chat. She said, neither Dawkins nor Collins have commented on encoding or encode.
Yeah, ENCODE project. Yeah.
Gotcha.
Well,
yeah,
neither
they
of them
have
are
both.
genetic.
I've got quotes from both of them that have commented on it.
You what? I didn't hear that.
I've got quotes from both Collins and Dawkins that have commented on it. Actually, you've referred to the CRISPR debates I've had many times. I've quoted Collins many times on ENCODE and junk DNA in general, and CRISPR had no objection to it. I mean, I'm not sure where.
I don't remember. I can't comment on it. I don't know.
Gotcha.
Yeah, that's. I've got a quote from Richard Dawkins here. He had a book in 2009. What he said was, "It is a remarkable fact that the greater part of the genome might as well not be there for all the difference it makes." Then, after ENCODE, in a debate with, I believe it was Jonathan Sachs is his name, he said regarding ENCODE, he said, "I know there are some creationists who have jumped on it because they think it is awkward for Darwinism. Quite the contrary, of course. It is exactly what a Darwinist would hope for, to find usefulness in a living world." So you see that he's kind of embraced the ENCODE results. So I mean, there's a couple quotes right there for you.
I don't know that that's embracing it. That's embracing the work that they've done, and perhaps being open to the idea that there's more functionality than previously thought, which you're right, there is. But the question is how much, and you gotta, I'm telling you, current literature, you gotta stick with it.
Gotcha. We appreciate it. Next up, folks, thanks so much for all of your questions. It's been a true joy. We are going to wrap up just to let Erica get some sleep as she is in London. And so let's see if I remember right. Huh?
You're more tired than I am.
Yeah, that's probably true.
I'm getting pretty tired too.
I'm impressed. Go ahead. What were you saying?
Good 2-hour debate, Erica.
No, this is child's play. I stay up this late. Listen, I've been writing the same project proposal for months. I have to stay up later. I get nothing done.
Gotcha.
There's something called coffee.
Erica says you're a beta if you're tired already. So thanks so much.
That is, yeah. You're a virgin data, and I don't. What is it? Virgin beta cuck? Is that the phrase?
Very glad. Thanks so much. You're the first person that's ever said that on our channel. We appreciate that.
Oh, good. I'm really glad to hear that. That's my claim to fame.
A lot of triggered people out there right now. I appreciate that. That is good work, Erica.
I live to trigger. That's what I'm here for.
That's right. I like that. That's why we have you on.
Actually, quick question. I just caught a glance in the chat, and somebody was saying that I need to address Erica's LMN. Did you bring up? I don't think we discussed that in the discussion.
Yeah. So I mean, there were. Hold on a second.
I think I brought it up, and I was like, let's maybe discuss it, but then I don't think we actually did.
We can do that for a third debate, but it wouldn't be fair for me to jump to that question because there were a lot of other questions before that question, and it technically, I don't know if it was originally put in the form of a question, but so I can't jump ahead of that one. Otherwise, it'd be kind of cheating everybody else who was in line first.
Actually, from what I recall, is during the discussion, we were deciding.
We were not going to talk about it, Standing for Truth. I appreciate it. However, we are not going to. I don't want to just ignore all the questions that came in before that. So, thank you very much. If you'd like, there's always a possibility for a third debate. And like I said, I don't want to, for all the people that asked the question before Jeremy at War, I don't want to just ignore theirs. So, thanks so much, folks, for being here. It's been a true pleasure. Erica, what were you going to say? I think I didn't mean to cut you off. I was happy to cut Standing for Truth off, but
no, I was saying that you were
master, James.
I said standing, go easy on James. He's exhausted.
Listen, Standing for Truth, my old arch nemesis. But by the way, do want to mention, folks, very excited. As if you didn't know already, I'd maybe mentioned it before, but in case you hadn't seen, we are pumped for the fact that not too far away, actually, we do have a sweet event that we're excited about. If you enjoy Standing for Truth for some reason, we are pumped about the fact that we are going to have none other than Standing for Truth's father. He is going to be on shortly, and that is actually none other than Kent Hovind, or Daddy, as Standing calls him. So that's you'll see that on the bottom right. That will be the end game of their trilogy of debates.
But James, I could have gone my whole life without hearing that Standing refers to Kent as Daddy.
Yes, he does. So,
James, you made that up.
Okay, I maybe made that up. He doesn't really, but I might start telling people he does. So it's been fun, folks. Both of our speakers are linked in the description, though. So I want you to know, folks, if you've enjoyed listening to them, I forgot to mention this up front. If you've enjoyed and you're like, I want to hear more, well, you can. I've put their links conveniently down below in the description. They're waiting for you right now. Actually, I just noticed, Standing, seriously, this is a coincidence. I haven't put yours in there yet, but I'm putting it in there right now. So do want to let you know, folks, we do want to be open to topics. So feel free, if you happen to have any topics, please let us know, as we do want to have more topics, new formats like tag team, triple threat, other things. Like it does help us a lot if people let us know, like, hey, I like this or I don't like this. So feel free to give us that feedback. And now Standing for Truth is officially, he officially has his link down in the description. And so again, thanks. Those links of both Erica and Standing are down in the description if you've enjoyed and want to hear more of them. And thanks for being here, everybody. Thanks so much for your questions. And most of all, we really appreciate Standing for Truth and Erica being here, staying up late and debating for us. We appreciate you guys being here.
Always a pleasure, James.
Always a blast, James. You know that. I'm looking forward to the next debate.
Always a true joy. So with that, keep sifting out the reasonable from the unreasonable, everybody. We hope you take care and have a great night. We'll see you tomorrow with Tom Jump and Benjamin Blake Speed Watkins debating the definition of atheism. So take care. We'll see you tomorrow.